talk about my yeah. I will talk today about my research, which was about school clustering through machine learning and geospatial analysis. So moving on to a bit of background, it's worth mentioning that in Mexico there is an official standard designed by experts in which they suggest what are the best conditions to select a piece of land to build a school. Taking into consideration the conditions from the environment, both natural and infrastructural ones. So this document is the one that we see here in the screen. It's the Norma Mexicana NMX R003 SC3FY 2011. So this is the first page, and these are the other ones in which the conditions are like detailed. Uh, in addition to that, it's worth mentioning as well that there is already official information available regarding where the schools in Mexico are located. So in particular, this data set is this one that we are seeing in the screen, which is the National Statistical Directory for Economic Units, or the NUE, and it's produced by INEGI. Based on multiple economic census that they perform. As we can see, it is displayed as a point file, and it has a national coverage. So, as mentioned, the standard itself mentions some conditions that the schools need to fulfill in order to not represent any like risk or something. So these are the ones that are explained in this document. For example, for the natural ones, we have, for example, geologic faults, as well as proximity to landslide zones, to flood zones, etc. As for infrastructural ones, we have the proximity of schools to roads, fuel depots, highways, and so on and so forth. As for the problem statement, it's where we can say that the school environment actually has a direct impact in the students' health, safety, motivation, and academic performance. So it's essential to perform a planning about the location of the schools in order to make sure that the conditions are safe and the community is prepared for emergencies. So the objective of the research was to generate a machine learning model, selecting an algorithm and using geospatial analysis techniques to produce a data set that will tell us if the schools in Mexico comply or not comply with the standard. It's worth mentioning as well that it's not a risk assessment study as per se. It only tries to describe and identify the hazard features, but it doesn't try to calculate probabilities of a disaster to happen. So a related work was done to review literature available. So for this, 10 studies were consulted, and it was found that there has not been enough research with regards to the compliance of the existing school infrastructure based on this standard, as well as it was proven that there has been documentation that there is actually a relationship between the proximity of these hazardous features and the schools in both the safety and health of school population. And 3, it is possible to use unsupervised machine learning algorithms to cluster facilities like schools based on their attribution. As for the methodology, the research design was performed by using the CRISP-DM methodology, which is cross-industry standard process for data mining, which consists in 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. As for the data collection part, as mentioned, for the research, it was used the NUE school data set, but this one didn't have all the necessary attributes regarding hazardous conditions. So for that, it was necessary to look on other files that were also produced by INEGI. So for this reason, these other 5 data sets were consulted, in which it was included statistic units, topographic data, geological data, weather management data, and urban waste data. So as for the experimental setup, it consisted on 3 steps. In the first one, the dataset was created to determine if the schools were compliant or not with the standard. After that, this dataset was used in a machine learning algorithm to create a model and group all the schools in Mexico into multiple clusters. And finally, with this model, an interpretation of the results was performed. For creating the dataset, the main tool that was used was Python, specifically the Pandas and GeoPandas libraries. For this, the shapefile of schools was loaded into this programming language, and then the proximity of each school to the closest features of the ones that were mentioned was calculated. The shapefile had a dimension of 148 records for 42 columns. This is an example of what the dataset looks like. It pretty much has all the schools in Mexico, and it has the distance for each school to the nearest condition of the evaluated ones. So for example, this last record, it's about the Colegio de Bachilleres in Yucatan, and it has its coordinates, and we can see here what the distance were for flood zones, roads, railroads, etc. After determining the distance, these flag attributes were created to tell us if the distance was according to the standard. The ones that had a 1 are the ones that didn't met the standards requirements. For example, for this last record, again, in Yucatan, we can see that these last 2 values had a 1, which is because this particular school was very close to a road and a railroad. As we can see, it was only 33 meters and less than a meter. So that's the reason why it had a 1. So after creating this binary data set, the model was produced by using, again, the Python programming language, but this time the libraries that were used were scikit-learn, NumPy, and K-modes. So what was done here was to select an algorithm for clustering the schools, and the script tested a range of cluster numbers, in this case from 2 to 15, using this algorithm, which was selected because of the nature of the data, which was binary and categorical. So we can see that the K-modes algorithm is an unsupervised machine learning algorithm, which is categorized as a partitional algorithm. So what the algorithm tries to do is to seek to create a group of data, maximize the similarity between objects within the same group, while minimizing the similarity between objects assigned to different groups. It initializes a cluster centroid and uses the mode, which is the most frequent value in each attribute. Then each data point of school is assigned to the cluster whose centroid it is closest to by calculating this matching count for each categorical attribute. And in addition to doing that, some evaluation metrics are produced to determine what the quality of the clustering was. So for this, the silhouette score, the Kalinski-Harabasz index, and the Davis-Baldwin index are calculated for each of the models produced. So as we can see here in the graphs, we can see that what we were looking for in this case was to have the model with the highest silhouette score and Kalinski-Harabasz score and the lowest Davis Baldwin index score, because yeah, it indicates us that the quality is the better one. So in this case, we can see that the model that have like the best combination of metrics in this case was the one with 11 clusters. And after creating this or getting all this model, it was possible to implement these labels to the original data set. So now each of the schools in Mexico has a label indicating to which cluster it belongs, as we can see here. And finally, as for the analysis of results, this table was created in which we can see what the distribution of schools is between the clusters and what the percentage of schools is contained in each cluster and what the cluster actually means. For example, the cluster in which most of the or the majority of schools was like grouped was this one, in which 31% of the schools fall, and these are schools that are very close to a road. After that, there is a cluster in which 25% of the schools were grouped, and in this one, the schools they don't have any close hazard to mention. And the third one is the one in which the schools are close to a road and a field depot, and so on and so forth. The results are sorted from the higher percentage to the lowest one. So at the end, the count of schools was a little lower than the original data set, because the original data set had like duplicate records, and it had also schools that were out of the scope of the standard. So those were excluded in the data set creation part. And well, these are the results of the analysis. For the implication of the study, the research demonstrated that it's possible to use advanced geospatial analysis and machine learning to identify and address natural and human-made hazards affecting school infrastructure. The study has social relevance because it looks to protect school populations, promoting and also it shows that there's a positive social impact of using scientific research and advanced technologies. As for the limitations, the study faced limitations because there were missing data that was not possible to consult, because it was not produced. But 72% of the conditions that were mentioned in the standard were implemented in this research. Also, the standard, it wasn't too clear on exactly what distance to use for some of the conditions. So for this reason, a default value had to be used based on the other values that were actually like stated in the standard. And there are also limitations in terms of the metrics for evaluating the quality, because it is always good to also have other complementary validation methods to make sure that our results make sense. So in conclusion, this study used machine learning and geospatial analysis to create models that detect and group schools located near potentially hazardous natural and infrastructural conditions. And the evaluation phase confirmed that the clustering was effective and of good quality. It highlighted the importance of making schools communities aware of nearby hazards to implement measures that ensure safety and health. And that's it. Thank you so much.
Thank you. We now allow space for questions in the audience. If you have one, you may raise your hand. Yes. You may open your microphone.
Hello. Really nice presentation. Thank you a lot. My question, if you try to map the results of the clustering, and because now you present how the groups were formed, but I would like to know if you map them.
When you say map them, is like creating polygons from them, or
to show in a map the points, how they spread in a
yeah,
map.
yeah, it actually looks like the screen, the screenshot that I shared. Let me see if I can share it. I have it in QGIS, so let me see. Um, mm, well, I don't see the option, but yeah. Well, what I did was to have like the output that I presented, and it is displayed as a J file. So yeah, it's possible to display it as a map. Yeah.
Yeah. My question was in the sense, if you see also clusters in space, or they were mixed in the territory.
Mm, yeah, it looks like the points tend to group themselves spatially, so they are clustered. They were not created like polygons; they were only points, but they look like clusters. Yeah.
Okay, thank you.
Mhm.
Okay. Well, that concludes our session for questions. Thank you, Doctor, for your presentation.
Mhm. Thank you.